Bismillahirrahmanirrahim. Today we are going to start chapter 2, Matrices. What is a matrix? A rectangular array. Array means arrangement of numbers enclosed in large square brackets or parentheses is called a matrix. This is in square brackets and this is in parentheses. So these two are matrices. Now the horizontal lines are called rows and the vertical lines are called columns. So here are 2 rows and 2 columns. Here also 2 rows and 2 columns. Order of a matrix. Order of a matrix. If a matrix A has m rows and n columns, then m multiply n or m cross n. So we will read it as m by n. The m by n, this is the order of matrix, is called the order of matrix A. Now look here. Here are 1, 2, 3. 3 rows and 1, 2 columns. So its order is 3 by 2. 3 by 2. Here 2 rows and 2 columns, so 2 by 2. Here 1 rows and 2 columns, 1 by 2. 2 and here 1 by 2. Equality of 2 matrices. 2 matrices of the same order, their order should be same. Order means number of rows and columns should be equal. 2 matrices of the same order are said to be equal when their corresponding elements are equal. Now look, A and B are 2 matrices. P is equal to P, Q is equal to Q, Q, R and R are corresponding elements, S and S are corresponding elements. So the corresponding elements of A and B are equal. That's why matrix A and B are equal. Types of matrices. Row matrix or row vector. A matrix having a single row is called row matrix, and a matrix have a single column is called column matrix or column vector. Next, square matrix. A matrix is said to be square if its rows, number of rows are equal to its number of columns. Look here, 2 rows and 2 columns, it is a square matrix. 3 rows and 3 columns, it is a square matrix. Now this is main diagonal or principal diagonal or leading diagonal, and this one look here, this AD represents main diagonal and this CD it represents secondary diagonal. Now rectangular matrix. A matrix is said to be rectangular matrix if the number of rows is not equal to the number of columns. Now look here, 2 rows and 3 columns, it is a rectangular matrix. Here 3 rows and 4 columns, it is a rectangular matrix. Diagonal matrix. A square matrix is said to be diagonal matrix if its main diagonal, the other elements are 0 other than the main diagonal elements. Now look here, 0, 2, 3, this is the main or principal or leading diagonal. The other numbers are the elements, other elements. These 0, 0, 0, 0, these are the elements of the matrix. So we can say that a square matrix is a diagonal matrix if all its non-diagonal elements are 0. These are diagonal elements, so non-diagonal elements are 0. This is called diagonal matrix. Now scalar matrix. A A square matrix is called scalar matrix if its non-diagonal elements are 0 and the diagonal elements are equal. Now look here, k, k, k are this example. 2, 2, 2, this is a scalar matrix. Unit matrix. A square matrix is called unit matrix if its non-diagonal elements are 0 and the diagonal elements are all equal to 1. Here 1, 1, 1. Look, these are the example of unit matrix. Look here, 1, 1, 1, 1, 1 in the main diagonal, 1, 1, 1. 0 are null matrix. A matrix whose all elements are 0 is called a 0 or null matrix. Example are this. These all are null matrix. Transpose, when we change the rows into column, so this is called transpose of a matrix. Now upper triangular matrix. A matrix is said to be upper triangular if all the elements below the principal diagonal are 0. This is principal diagonal, all the elements are 0 below it, so this is upper triangular. Look here, this is the principal diagonal or main diagonal and all the elements below this are 0. This is upper triangular. Similarly, lower triangular matrix. A matrix is said to be lower triangular if all the elements above the principal diagonal are 0. So this is lower triangular matrix. Now what is triangular matrix? A matrix is said to be triangular if it is either upper or lower triangle. Symmetric matrix. When we take the transpose of a matrix and it becomes equal to the original matrix which is given, so it is called, the matrix is said to be a symmetric. Or a matrix A is said to be symmetric if A transpose equals to A. Skew symmetric. A matrix A is said to be skew symmetric if A transpose equals to minus A. Algebra, addition, multiplication, and this I will discuss it in exercise commutative property and etc. So come to the exercise. Let's start 2.1 exercise. Exercise 2.1, question number 1, express the following as a single matrix. Solution. First multiply these two. First row into first column. 1 multiplied by 1 plus 2 multiplied by 2 plus 4 multiplied by 0. First row with second column. 1 multiplied by 0 plus 2 multiplied by 0 plus 4 multiplied by 1. Now first row with third column. 1 multiplied by 2 plus 2 multiplied by 1 plus 4 multiplied by 2. And close the bracket and write this matrix on its place. 2, 4, 6. Now look, 1 multiplied by 1, 1, 2 2s are 4, 4 zeros are 0. Here 1 zeros are 0, 2 zeros are 0, 4 ones are 4. Here 1 2s are 2, 2 1s are 2, 2 4s are 8. Write this matrix 4, 2, 4, 6. Now 5, 4, 12 into 2, 4, 6. Now again multiply row into column. 5 into 2, 4 into 4, 12 into 6. Look here, 5 into 2, 4 into 4 plus 12 into 6. Now 5 2s are 10, 4 4s are 16, 12 6s are 72. Add these, we get 98. The answer. Now part 2. Part 2. 1 minus 2 3 into 2 minus 1 5 0 2 4 minus 7 5 0 minus 2 minus 5 7. Solution. First row with first column, 1 into 2 plus minus 2 into 0 plus 3 into minus 7. First row with second column, 1 into minus 1 plus minus 2 into 2 plus 3 into 5. Now first row into third column, 1 into 5 plus minus 2 into 4 plus 3 into 0. Close the bracket and write minus 2 minus 5 7. Now look at here, 2 1s are 2, 2 0s are 0, 3 7s are minus 21. Here 1 1s are minus 1, 2 2s are minus 4, and 3 5s are 15. Here 5 1s are 5, 2 4s are minus 8, and 3 zeros are 0. And close the bracket, minus, write 2 minus 5 7. Now look, 21 minus 2 we get minus 19. 15 minus 5 we get 10. And 8 minus 8 plus 5 we get minus 3. Minus 2 minus 5 7. Write this. Now minus 19 minus 2, 10 minus minus 5, minus 3 minus 7. Now look, we get minus 21. Here 10 minus into minus plus 5, and here minus 10. Minus 21, 15 minus 10. The answer. Part third. Solution. Row into column. 7 into 3 plus 1 into 4 plus 2 into 5. Second row into first column. 9 into 3, 2 into 4, 1 into 5. Plus, multiply these two here. 2 4s are 8 and 2 2s are 4. Now look, 3 7s are 21, 4 1s are 4, 2 5s are 10. 9 3s are 27, 4 2s are 8, 5 1s are 5. 8 4. Now look, 21 10 31 4 35, 27 and 5 32 8 40. 8 4. Now 8, 35 plus 8 and 40 plus 4. 35 plus 8 we get 43 and 44. The answer. 4. Solution. First of all, add these two. So we can write it as 1 plus 3, 3 plus minus 2, minus 1 plus minus 1, minus 4 plus 1. 1, 3, 5, 2, 4, 6 on its place. Now remove these two brackets. 3 plus 1, 4. 3 minus 2 we get 1. Minus 1 minus 1 we get minus 2. Here is plus, and minus 4 plus 1 we get minus 3. 1, 3, 5, 2, 4, 6. Now multiply these two. First row with first column. 4 multiplied by 1 plus 1 multiplied by 2. First row with second column. 4 multiplied by 3 plus 1 multiplied by 4. First with third. 4 multiplied by 5, 1 multiplied by 6. Now second with first. Minus 2 multiplied by 1 plus minus 3 multiplied by 2. Minus 2 multiplied by 3 plus minus 3 multiplied by 4. Minus 2 multiplied by 5 plus minus 3 multiplied by 6. You can write this in bracket also, because here are two operators, plus and minus, that you may not confuse here. Now 4 1s are 4, 2 1s are 2, 4 3s are 12, 4 1s are 4, 4 5s are 20, 6 1s are 6, 2 1s are minus 2, and 3 2s are minus 6, 2 3s are minus 6, and 3 4s are minus 12, 2 5s are minus 10, and 3 6s are minus 18. Now look, 4 plus 2 6, 12 plus 4 16, 26, minus 8, minus 18, and here minus 28. This is the answer.